In this video, we'll explore how to construct a basic retrieval-augmented generator using Python, enhancing your AI models with dynamic data retrieval and improved response generation. Have you ever wondered how AI models can generate more accurate and contextually relevant responses? Well, it all boils down to a cutting-edge concept known as Retrieval-Augmented Generation, or RAG. RAG allows AI to retrieve relevant data dynamically, leading to impressive improvements in response generation. In this video, we're diving deep into how you can build a RAG system using Python, a skill that's becoming increasingly vital in the AI landscape. From setup to optimization, you'll learn everything needed to integrate retrieval mechanisms into your Python-based generation systems. Let's get started.
Before we dive into building our RAG system, we need to ensure our Python environment is ready. Start by setting up a virtual environment, which is critical for managing dependencies without conflicts. Use the command python mven_vrag_env to create a new environment. Once activated, we'll need some essential libraries like NumPy, Pandas, and scikit-learn. You can install these using pip install NumPy Pandas scikit-learn. Configuring your IDE for Python development will streamline your workflow. Consider using VS Code or PyCharm, which offer excellent support for Python projects. Remember, a well-prepared environment is key to smooth development. Now that our environment is set, let's implement a basic retrieval mechanism. Retrieval mechanisms are the backbone of RAG, allowing your model to access and use external data sources. We'll start by coding a simple retrieval function in Python. This function will fetch data from an API. Here's a quick example using Python's requests library. Import requests, response equals requests.get https://api.example.com/data. Data equals response.json. This code fetches JSON data from a hypothetical API. Remember to handle errors gracefully by checking the response status and implementing retries for network issues. Retrieval mechanisms pave the way for dynamic and contextually aware AI models.
With retrieval in place, it's time to integrate it with a generation system. A retrieval-augmented generator not only fetches data but uses it to craft informative responses. Start by scripting a simple generator that leverages the retrieved data. Here's a basic approach: def generate_response data, return response based on data. This function takes data as input and generates a response. Test your integration by checking if the generator uses the retrieved data effectively. Watch out for common integration pitfalls, such as data format mismatches and API latency, which can affect performance. Debug thoroughly to ensure smooth operation.
Efficiency is crucial in retrieval-augmented generation systems. Optimized retrieval processes not only speed up data access but also reduce computational costs. One effective optimization technique is caching. By storing frequently accessed data locally, you reduce the need for repeated API calls. Libraries like Request Cache can simplify this process. Additionally, evaluate your API call frequency and batch requests to minimize server load. Improving data processing speed can be achieved by parallelizing operations using Python's multiprocessing module. Always monitor performance metrics to identify bottlenecks and refine your approach. Optimization ensures your RAG system remains responsive and cost-effective. Testing is an integral part of developing a reliable retrieval-augmented generator. Begin by validating data retrieval processes to ensure data accuracy and consistency. Use test cases that cover various data scenarios and edge cases. Python's Unitas framework is perfect for automating these tests. Next, focus on validating the generated responses for accuracy and relevance. Implement evaluation metrics to measure performance objectively. Continuous testing is vital for identifying and fixing issues as they arise, allowing for iterative improvements. Remember, a well-tested RAG system is more reliable and user-friendly, providing consistent and accurate responses. Developing a retrieval-augmented generator comes with its own set of challenges. One common issue is dealing with data inconsistencies from external sources. Implementing data validation checks can help mitigate this. API limitations, such as rate limits, require strategic planning to avoid disruptions. Real-time data processing is another hurdle, necessitating efficient coding practices and optimization techniques. Balancing retrieval speed with processing speed is crucial to maintain system performance. Lastly, as your system grows, ensuring scalability becomes essential. Design your architecture with scalability in mind, allowing it to handle increased data loads and user requests seamlessly. The future of retrieval-augmented generation is promising, with several exciting trends on the horizon. New retrieval technologies are emerging, offering faster and more efficient data access. Integration with AI advancements, such as deep learning and neural networks, is set to enhance RAG systems' capabilities. Machine learning is playing a significant role in refining retrieval processes and response generation. The potential for real-time RAG systems is becoming a reality, allowing for instantaneous data-driven responses. Moreover, RAG's role in AI personalization is growing, enabling more tailored user interactions. Staying abreast of these trends will ensure your RAG systems remain cutting edge.
We've covered a lot in this video, from setting up your Python environment to exploring future trends in retrieval-augmented generation. By now, you should have a solid foundation for developing your own RAG systems. Remember, integration and optimization are key to building efficient and effective models. I encourage you to experiment with different data sources and techniques to innovate your systems. Share your experiences and feedback in the comments below, and let me know what topics you'd like to explore next. Don't forget to like and subscribe for more content on cutting-edge AI technologies.